Just off the western edge of the Bahamas, where the water shifts from clear turquoise to deep blue, lies a stretch of seabed that has puzzled divers and scientists for decades. It sits near North Bimini Island, only a few meters below the surface, easy to reach compared to many deep-sea mysteries. Yet its simplicity is exactly what makes it so difficult to explain. In 1968, a group of divers exploring the shallow waters near Bimini noticed something unusual beneath them. Instead of scattered rocks or coral, they found a long line of large stone blocks resting side by side. The stones were mostly rectangular, some measuring several meters across, arranged in a way that felt deliberate. The formation stretched for hundreds of meters, gently curving along the coastline like an ancient road or harbor wall. This discovery quickly became known as the Bimini Road. At first glance, it looked artificial. The stones appeared stacked or fitted together, forming a single layer that resembled paving. The water depth was shallow enough for snorkelers to see it clearly on calm days. Unlike many underwater ruins, this was not hidden in darkness or buried in sediment. It was open, visible, and quietly waiting. The timing of the discovery played a major role in how it was received. During the 1960s, interest in lost underwater cities was growing fast. The idea of Atlantis, popularized by writers and explorers, was firmly planted in the public imagination. When news spread that a stone road had been found underwater near the Bahamas, some immediately linked it to ancient legends. Early reports focused on the visual impact rather than careful measurement. Photos showed straight edges and right angles. Divers described stones that looked cut rather than broken. For many, this was enough to suggest human construction. If true, it would mean a lost civilization once existed here, now submerged beneath rising seas. Geologists were more cautious. When scientific teams began studying the Bimini Road, they focused on the stones themselves. Most were made of limestone, a common material in the Bahamas. Limestone forms naturally when sand, shells, and coral fragments are compressed over time. In coastal environments, it can harden into what is known as beach rock. Beach rock often fractures in straight lines. As tides rise and fall, cracks form along natural stress points. Over time, these cracks can create large, flat blocks with sharp edges. Storms and wave action can then move these blocks short distances, sometimes lining them up in ways that look planned. This explanation became the foundation of the natural formation theory. Researchers examined the thickness of the stones, their composition, and how they fit together. In many cases, the blocks were not stacked but resting on the same level. There was no evidence of mortar or binding material. Beneath the stones, the seabed showed no signs of excavation or foundation work. These details suggested the formation had not been built upward, but fractured in place. Still, the debate did not end there. Some archaeologists and independent researchers argued that natural processes alone could not explain the consistency of the alignment. They pointed out that certain stones seemed deliberately placed, overlapping in a way that suggested human adjustment. Others noted that the formation curved gently, matching the shape of the coastline, which could indicate planning rather than chance. Dating the stones proved difficult. Limestone is notoriously hard to date directly. Some samples suggested ages of a few thousand years, while others appeared much younger. Critics of the ancient civilization theory argued that if the stones were relatively recent, they could not belong to a lost prehistoric culture. Supporters countered that erosion, sea level change, and sample contamination could affect results. Sea level history added another layer to the mystery. Around 6,000 to 8,000 years ago, sea levels were lower. Areas now underwater would have been exposed land or shallow shoreline. This raised a reasonable question. If humans lived in the region during that time, could they have built something along the coast that later became submerged? There is evidence that early human populations existed in the Caribbean region thousands of years ago. However, there is no confirmed evidence of large-scale stone construction in the Bahamas from that period. No tools, no settlements, no supporting artifacts have been found near the Bimini Road. That absence matters. Underwater archaeology relies heavily on context. A single structure without surrounding signs of human life is difficult to interpret as cultural. Roads, walls, and harbors are usually part of a larger system. At Bimini, only the stone alignment exists. Beyond it, the seabed returns to sand and coral. Over time, the Bimini Road became one of the most discussed submerged structures in the world. It appeared in documentaries, books, and online videos about unexplained ruins and lost underwater cities. Like the Baltic Sea anomaly, it was often presented without nuance, framed as either absolute proof of Atlantis or completely dismissed as a hoax. The truth, as usual, sits somewhere in between. Most geologists today agree that the Bimini Road is likely a natural beach rock formation shaped by erosion and fracturing. Yet they also acknowledge that its appearance is unusually orderly compared to many similar formations. That visual order is what keeps the discussion alive, even after decades of study. What makes the Bimini Road especially important is not whether it proves the existence of a lost civilization, but how it shows the difficulty of interpreting sunken structures. Shallow water does not mean simple answers. Even easily accessible sites can challenge assumptions about what is natural and what is made. As research continues and new underwater mapping tools become available, sites like Bimini are being re-examined with fresh eyes. High-resolution scans and 3D modeling may one day settle the debate more clearly. For now, the Bimini Road remains a quiet line of stone beneath clear water, balanced between geology and archaeology. As the Bimini Road became more widely known, it was impossible to separate it from the shadow of Atlantis. That connection did not come from archaeologists or geologists, but from popular writers who were already searching the Atlantic Ocean for signs of Plato's lost city. One of the most influential voices was Edgar Cayce, a well-known American mystic who, decades earlier, had predicted that remains of Atlantis would be found near Bimini in the late 1960s. When the stone formation was discovered in 1968, many people saw it as a fulfillment of that prediction. This association changed the conversation almost overnight. Instead of asking whether the stones were natural or human-made, many discussions jumped straight to what kind of civilization could have built them. Media coverage often led with the Atlantis angle, even when researchers involved in the surveys avoided making such claims. For scientists, this created a problem. Once a site becomes tied to legend, it becomes harder to study it objectively. Serious researchers responded by tightening their focus on evidence. Geological surveys became more detailed. Diverse measured individual blocks, mapped their positions, and documented how they rested on the seabed. One key observation was that the stones varied in thickness and shape more than expected for a constructed road. Some were long and flat. Others were uneven, cracked, or partially buried. This variety suggested natural breakage rather than deliberate shaping. Another important detail was the layering beneath the stones. In man-made roads or walls, there is usually preparation beneath the surface. Soil is cleared. Foundations are laid. At Bimini, the stones sat directly on sand and smaller rock fragments, with no sign of underlying structure. This supported the idea that they had fractured and settled in place rather than being transported and arranged. Researchers also studied similar beach rock formations in other parts of the world. Along coastlines in Australia, the Mediterranean, and the Caribbean, naturally fractured limestone platforms showed strikingly similar patterns. When exposed and submerged repeatedly over thousands of years, these platforms can split into rectangular blocks and shift slightly due to wave action. In some cases, they even form long, straight alignments. What made Bimini different was how visible it was and how early it entered popular culture. Unlike deep-sea ruins that require advanced equipment to reach, the Bimini Road could be photographed by snorkelers. Anyone could swim above it and draw their own conclusions. This accessibility helped keep the mystery alive, even as academic interest slowly cooled. Still, some questions remain open. The gentle curve of the formation continues to attract attention. Natural rock fractures often follow straight lines, but the Bimini Road bends gradually, almost like a shoreline feature. Geologists argue that this curve matches ancient coastlines and tidal patterns. Critics argue that it looks intentional. Without direct evidence, both interpretations remain possible. Sea level rise plays a central role in understanding the site. At the end of the last ice age, melting glaciers caused oceans to rise worldwide. Coastal features that once sat at the water's edge were slowly submerged. Many known submerged settlements exist today because of this process. The difference is that those sites usually contain tools, pottery, or other signs of daily life. At Bimini, none have been found. Underwater archaeology depends on patterns, not single structures. A road usually leads somewhere. A harbor connects to a settlement. When those connections are missing, archaeologists hesitate to label a site as cultural. This does not mean early humans were incapable of building in coastal areas. It means there is no supporting evidence here yet. Over the years, small-scale surveys have continued, often led by independent researchers rather than large institutions. These studies have added detail but not resolution. The formation remains what it has always been: a line of stone that looks ordered enough to question, but ordinary enough to resist bold claims. In many ways, the Bimini Road reflects a larger tension in the study of ancient ocean discoveries. The ocean hides history, but it also reshapes it. Water erodes, breaks, and rearranges material in ways that can mimic design. Without careful context, the line between natural and constructed becomes blurred. Today, most textbooks describe the Bimini Road as a natural beach rock formation. At the same time, it continues to appear in discussions of lost underwater cities and unexplained ruins because it challenges the eye. It asks viewers to slow down and consider how much appearance influences belief. The site is now protected, limiting disturbance and large-scale excavation. This preserves it but also means answers will come slowly, if at all. New technologies like detailed 3D seabed mapping and improved dating methods may one day offer clearer conclusions. Until then, the stones remain where they are, shaped by time, waves, and interpretation. As the conversation around Bimini has matured, it has become less about proving Atlantis and more about understanding coastal geology and early human movement. That shift is important. It moves the site out of legend and back into careful study, where it belongs. Off the southern coast of Japan, where the East China Sea meets the Pacific, lies a rocky landscape that feels out of place beneath the water. The currents are strong here, the waves unpredictable, and the seafloor drops away sharply from the shore. In 1986, a local diver named Kihachiro Aratake was exploring these waters near Yanaguni Island when he noticed something unusual below him. Instead of scattered rocks or coral, he saw massive stone surfaces arranged in steps and terraces. At first, Aratake assumed he was looking at a natural reef shaped by erosion. But the more he explored, the stranger it appeared. The surfaces were flat. The edges were sharp. Some angles looked close to right angles. There were long straight lines that ran for tens of meters. It did not resemble the irregular shapes most divers expect to see underwater. Aratake reported the site to researchers, and soon it caught the attention of marine geologists and underwater archaeologists. When they surveyed the area, they found that the structure was enormous. The main formation measured roughly 150 meters long and 40 meters wide, rising from the seabed like a stepped pyramid. There were what looked like staircases, platforms, and flat terraces, all carved from solid rock. This discovery became known as the Yanaguni Monument. Unlike shallow sites such as the Bimini Road, Yanaguni lies deeper and in rougher waters. Diving conditions are difficult, and strong currents limit how much time researchers can spend there. Even so, repeated surveys confirmed that the structure was real and extensive. It was not a trick of light or a single rock. It was a massive formation carved into the bedrock itself. The key question emerged quickly: was it natural or human-made? One of the strongest voices in the discussion was Professor Masaaki Kimura, a marine geologist from the University of the Ryukyus. Kimura studied the site for years and argued that the structure showed signs of human modification. He pointed to features that looked like carved steps, straight walls, and even what he believed could be roadways or ceremonial spaces. Kimura suggested the monument might be more than 10,000 years old, dating back to a time when sea levels were lower and the site would have been above water. If true, this would place the structure far earlier than most known stone architecture. It would challenge established timelines of human development in East Asia. For this reason, the claim drew intense scrutiny. Other geologists strongly disagreed. They argued that the rock at Yanaguni is sandstone, which fractures naturally along straight lines and flat plains. When exposed to waves, currents, and seismic activity, these fractures can widen and create step-like formations. Over thousands of years, erosion can sharpen edges and flatten surfaces, especially in tectonically active regions like southern Japan. They also pointed out that the area experiences frequent earthquakes. Fault lines can cause large blocks of rock to shift and break cleanly. What appears to be a staircase could simply be a series of natural fracture planes exposed by erosion. Unlike confirmed underwater ruins, Yonaguni has no artifacts, no tools, no pottery, no carvings with clear symbols, no evidence of habitation nearby. For many archaeologists, this absence is decisive. Structures built by humans usually leave behind cultural debris. At Yonaguni there is only rock. Still, the site resists easy explanation. Even skeptics admit that the scale and geometry are unusual. Some features run in parallel lines over long distances. Certain corners appear surprisingly precise. These details are what keep the debate alive. Dating the structure is especially difficult. Since it is carved from bedrock, there are no organic materials to test. Researchers rely on sea level models and erosion patterns instead. These methods can suggest timelines, but they are not exact. As a result, estimates vary widely. Public reaction to Yonaguni followed a familiar path. Documentaries and online videos often framed it as proof of a lost advanced civilization. Others dismissed it entirely as a natural cliff underwater. The reality is more complex. Yonaguni sits at the intersection of geology and archaeology, where both disciplines see part of the answer but not the whole picture. Over time, some researchers proposed a middle ground. They suggested that the formation is mostly natural but may have been modified by humans at some point. Simple shaping, leveling, or use of existing rock surfaces could explain why some features appear more ordered than others. However, this idea remains speculative without supporting evidence. What makes Yonaguni important is not whether it proves an ancient civilization, but how it highlights the limits of underwater interpretation. When a structure is carved from solid rock, the line between nature and design becomes hard to draw. Underwater archaeology depends on context, and here, context is scarce. Today, Yonaguni remains one of the most debated submerged structures in the world. It continues to attract divers, researchers, and curiosity seekers. The Japanese government has monitored the site but has not declared it an archaeological ruin. Officially, it remains a geological formation under study. As with many ancient ocean discoveries, Yonaguni teaches caution. It shows how powerful natural forces can create shapes that challenge our assumptions. It also reminds us that human history near the coast may be more complex than written records suggest.